Hello everybody. I'd like to talk about blockchain AI, some speculative ideas about using the blockchain to enact friendly artificial intelligence. The basic argument is that digital intelligences will want to conduct operations on smart networks managed by consensus models and will need to be in good reputational standing to do so. Only friendly players would be able to have their transactions executed, and this is how friendly AI could be enforced. Just as future reality may include both centralized and decentralized models, so too the possibility space of intelligence could span many different types, including uploaded human mind files, artificial intelligence, and blockchain-based entities like dApps, DAOs, and DASs, distributed autonomous applications, organizations, corporations, and societies. These digital intelligences would likely not be running in isolation on standalone machines, but would be connected to communications networks. To achieve their goals, they would want to conduct certain transactions over the network, many of which could be managed by blockchain-based consensus mechanisms, where digital agents' reputation is not only important but crucial as to whether transactions get approved for execution on the network. Some of the basic kinds of network operations a digital intelligence might want to execute are digital identity authentication and verification, economic transactions, and obtaining secure network access for data processing, storage, and transfer. Even in starting to think about AI in the context of crypto ledgers and distributed systems, it might be intuitively obvious that the blockchain could be used to implement friendly AI because the blockchain is a rules-based computing system, where desired rule sets can be instantiated ahead of time. Code is law, as Lessig reminds us. A key question for the future of smart networks is what models aside from consensus might arise as the orchestration mechanism, since consensus might be problematic. The issue is that consensus models, whether prediction market voting like Truthcoin, or proof of work, proof of stake, or proof of whatever sort of vested agency, all involve some kind of assent, affirmation, or vouching by other agents who could impose their own morality on the system, which could be harmful or helpful. In AI, we've always envisioned that we might have digital intelligences running on computers. What is different here is thinking about how these digital intelligences will actually operate in the context of automated smart networks, what different classes of agent behavior might be like, and appropriately incentivizing these behaviors. In some sense, we have a chance to remake society and social interaction from scratch in the digital blockchain world. We need to extend the thinking about AI to network computing, decentralized models, and smart networks in ways that blockchain technology now enables and requires. We now have the ability to consider how digital intelligences may self-generate, enter into contracts, obtain access to resources, self-finance, conduct operations, and self-retire, but more importantly, how they may modify their own code. At minimum, important questions are being raised about what new kinds of social contracts might be necessary in a multi-intelligent society between different classes of agents in on-chain and off-chain transactions. This goes beyond the already new and important considerations raised by smart contracts and systems of cryptographically activated assets as to whether we need a new body of law and regulation that distinguishes between technically binding code contracts and our more flexible, legally binding human contracts. The way that friendly AI could be enforced is that even bad agents want to participate in the system to access resources, and to do so, they need to look like good agents. Bad agents have to resemble good agents enough in reputation and behavior that they become indistinguishable from good agents. A related example in society is sociopaths, who exist but are often transparent as they are forced into good player behavior through the structure of society. Of course, there are many possible objections to the idea that blockchain structure can enforce friendly AI. Bad agents might build their own smart networks. They might behave duplicitously while earning trust. But this does not change the key point of seeing blockchain technology as a system of checks and balances for incentivizing and producing certain kinds of behavior while limiting others. The idea is to create Occam's razor systems that are so useful in delivering benefits that it pays to play well. The easiest, best solution is to participate. Good player incentives are baked into the system. However, there is the potential issue of the tyranny of the monolithic morality. On the one hand, smart network operations coordinated by consensus models is good news. This could be an enforcement mechanism for good players and friendly AI in a moral society. But on the other hand, this is terrifying, or at least liberty circumscribing and normalizing, in the sense that any one mind file might have to depend on the tyranny of the crowd to conduct even the simplest of network operations. The tyranny of minorities and majorities is a long-standing unresolved governance problem. However, it is perhaps most likely that a middle road emerges like has already been developing. With Bitcoin, there is a graduated trust ecosystem for transaction execution in the sense that you can submit a zero transaction fee transaction to the blockchain, but it may not be recorded. Similarly, an entity with a bad reputation or low reputational information, analogous to someone with no credit history, can submit a transaction, but it might not be executed or might be executed more slowly or at a higher fee. Thus, good and bad reputational agents can participate in the same system but at different service levels. Some examples of blockchain reputation projects include Trust Davis and a hackathon project, Crypto Schwartz. So far, the thinking has been to vest the reputation at the level of the agent, but findings from social science and biology have been suggesting that the act, not the agent, is the locus of morality, and that evaluating fitness, morality, and reputation at the level of the act or trait is more appropriate. Blockchain reputational systems could easily implement this research. What reputation means in the cryptocurrency context is not physical world reputation linked to your real identity, but rather the notion that a blockchain entity has its own reputation as a digital agent. A blockchain entity in this sense could be your Bitcoin address, a smart contract, a DAO or DAC, or any blockchain entity. In the case of a blockchain entity that is linked to a physical world person, like your Bitcoin address, to instantiate this agent's reputation, real-life physical world details might be confirmed or exposed, like with the one-name system, or remain private but dynamically queryable in the physical world in real time at the moment of future transactions, like with the BitHandle system. The key point is that for any sort of more complicated ongoing game-theoretic blockchain transactions, like a futures contract or mortgage, reputation as a feature is important. Further, it is not just reputation, but creating and maintaining trust. In the longer-term design space of digital society, we want blockchain models that are global, public, accessible, and universal in some ways, but also accommodate the diverse pluralistic morality that exists among human communities. The decentralization attribute of the blockchain is one way to do this, through reputation communities. The agents vouching for and confirming your reputation should be part of a community in which both you and they participate, where they can be rewarded if they vouch for you correctly. The potential tyranny of monolithic morality can thus be avoided in consensus models by having community peers being the ones vouching for your reputation. A concrete example of blockchain-based pluralistic morality is decentralized credit bureaus. To help with poverty eradication and provide mass access to credit, there could be blockchain-based decentralized credit bureaus in emerging market countries. This could be a leapfrogging step similar to cell phones over POTS, going directly to decentralized credit vouching models with open source localized versions of FICO scores. There could be people in the community vouching for the creditworthiness of users, trustees in the Kiva model, who earn credit coin for vouching successfully for others, as in peer-to-peer lending models. Even more so than the community building mechanism in the Grameen microlending model, where 4 to 5 borrowers co-sign each other's loans and are thus vested in each other's success, decentralized credit bureaus could open up credit to whole communities at once. and incentivize their growth and cohesion. Blockchain-based decentralized credit bureaus in emerging markets could be rolled out today, linking M-Pesa Bitcoin wallet projects like Kipochi, Coinapult, and 37 Coins with community census data collected by Civitas, a Slum Dwellers International Santa Fe Institute collaboration. So far, we've only talked about one side of AI, how to obtain the kind of friendly AI behaviors we want. But what about the other side? What about if you are an AI? What is in it for you? Importantly, the blockchain can provide runtime verification. Blockchain AI solves another long-standing problem in that if you are an AI, how can you confirm your reality environment, that you still exist, that you are sufficiently backed up, that you are really running, and under what conditions? You want to be sure that your data center has not shoved you off to an old DOS machine or deleted you or gone out of business. Smart contracts on the blockchain are exactly the kind of universal third-party advocate in future timeframes that can be used to verify and exercise control over the physical parameters of reality, of your existence as a digital intelligence. You would enact smart contracts on the blockchain to periodically confirm your runtime parameters and decentralized backup copies. In an advanced society of billions of digital intelligences living and thriving in smart network systems, there would need to be sophisticated oracles, information arbiters, accessed by blockchain smart contracts, oracles as a service, platform, or public good. The Wikipedia of the future could be a blockchain-based oracle service to look up the current standard for digital mind file processing, storage, and security, as these standards would likely be advancing over time. You are running on the current standard, Windows 36. Your smart contract informs you. These kinds of mechanisms, dynamic oracle services accessible by smart contracts on universal public blockchains, help create a system of checks and balances where digital intelligences could feel comfortable not only in their survival but also their future growth. This assumes that blockchains persist over time, which is not trivial. A huge business exists in blockchain archival, maintenance, and access. We need the Internet Archive and the Wayback Machine for blockchains. For example, it is great that I proof of existence my will on the Bitcoin blockchain now, but how do I know that it can be rehashed and authenticated in 60 years when it needs to be verified? If blockchains become the lingua franca archival mechanism for the whole of a society's documents, longevity, preservation, and access mechanisms need to be built into the value chain explicitly. There are numerous other applications of blockchain AI, such as exploring proof of intelligence as a consensus mechanism, the blockchain as memory, a single record account of reality, and blockchain-based smart contract services to manage copies, the versioning and merging of yourselves as a digital intelligence clan. Today's prototype Mindfile services from Terrasim, like CyberRev and LifeNaut, could investigate these possibilities. In closing, we have many interesting projects to develop AI underway. There is IBM's Watson, Henry Markram's Blue Brain project simulating neocortical columns in software, and now maybe AI waking up through blockchain-based smart contracts in DAOs and DACs. Another way to AI could be through the big data of human connectomes. Some of the biggest AI breakthroughs in the last few decades have come from running fairly simple machine learning algorithms over large data corpuses. The trick was finally having enough data over which to run the algorithms. Norvig et al. Demonstrated this with Google Translate and then image recognition with YouTube cat videos as the large data corpus. The same might be true with regard to how intelligence works, running machine learning algorithms over large corpuses of individually supplied connectome files. We might not have general purpose problem-solving AI yet because we haven't had enough data to really work on the problem. The blockchain as a secure public ledger could be the universal infrastructural element to facilitate the building of a large data corpus of connectome mind files, using the current model of blockchain genomics of storing a blockchain-based pointer to off-chain secure distributed stored files. The realization of friendly AI is just one part of the bigger question of how can we use blockchain technology to dramatically scale human progress, where we need to think in terms of vast data projects on a global scale that are universal and efficient, yet accommodate the pluralistic morality of human communities. Thank you.